Hello sir, good evening. This is Ritesh Lohiya and this is my final presentation for Data605 final project, and you can see my screen. This is an RPub, my RPub for the final project. Initially I downloaded all the libraries, and this is my problem one. So the problem one is pick one of the quantitative independent variable from the data set below and define that variable as x. Also pick one of the dependent variable below and define that as y. So I did that. I just created a small data set, did that, assigned it to x and y. Then I started with probability. And first thing what I did was getting the quartiles. So you can see I have calculated the quartiles here, and then started with my first problem, that is probability of x is greater than the small x given that y is greater than small y. It came out to 0.2. The second was probability of x greater than small x while y is greater than small y, so that probability came to 0.15. and the third one was probability of x smaller than small x given that y is greater than small y. For that I got the probability of 0.8. Then I did the table of counts, so you can see the table of counts below. Going to the next thing is does splitting the training data in this fashion make them independent, and for that we had to do some mathematical test. This is the mathematical test I did, and also I did chi-square test. We can see that probability of a given b is 0.2 and probability of a into probability of b is 0.1875. They are very near, therefore splitting the training data in this manner is going to make them independent. You can see the p-score is also 0.22, so we can reject the null hypothesis. We cannot reject the null hypothesis. Problem 2, where we have to take the data from the Kaggle, do some descriptive and inferential statistics. First step, and for the first step we did the scatter plot. We were asked to do take two variables. So my two variables were gross living area and sales price for the first plot, and for the second plot it was masonry winner area and sale price. So these are the two plots. Then I started with descriptive statistics and plots. And plots. So this is initially I did the summary to get the descriptive statistics. So this is the statistics. Then I did some bar plots to check the relation of these variables with the sale price, and you can see these are the box plots. Then I did some histograms for ordinal data to understand the spread of the data. So here are my histograms. Then then we had to do a correlation matrix for any three quantitative variables. So the variables I selected are sale price, total basement in square feet, and then gross living area. I did the correlation matrix here. Then I tested the correlation between each pair, that is total basement area in square feet and sales price first, then gross living area and sale price, and then gross living area and total basement area in square feet. So there was a question like, would you be worried about family wise error? Yes, the variables in the data set that might have impact on correlation of these the pairs of selected variables that are being tested here. So there is a scope of family wise error, I would say. Then we had to do some linear algebra and correlation. For that I did correlation matrix, and then I did precision matrix, multiplied correlation matrix with the precision matrix first, and then multiply precision matrix by correlation matrix. So I could see it's identical. We got the matrix, identical matrix. Then we did LU decomposition of correlation matrix, and similarly LU decomposition of precision matrix. Then again we multiply lower and upper matrix and see if it returns original matrices or not. So it did return original matrices. Then we had to do calculus based probability and statistics. So choosing one variable, so I chose gross living area. So I just tested what's the minimum value. Minimum value was 334. So I don't think we need shifting here. I found out the rate, and then I did do the using the fit distribution. I did the exponential probability density function, calculated that, and then plotted histograms for both. You can see the histogram for samples and originals. The sample is more skewed, I would say. You can see this is more skewed. And then we have to find the quantile, the 5th and the 95th. So that is I have done here. And for the modeling part, I started with data preparation. So before that, before doing anything, I just started with missing value treatment. What I did was I just combined the training and test data, and did the missing value. I saw what all missing values we have, and did some transformation for the missing values. This is my treatment for missing values. And then after that, I again plotted and see whether we have missing values. So I didn't see anything except for sale price, which was from the test data set. Then I did some outlier treatment, and then I started with building the model. For the first model, I took all the variables, and I can see that you can see that I have generated the summary as well. So this is my first variable, a lot of variables. First model. This is my first model. Yeah, you can see for the first model I got R square as 93%, I would say, and it's pretty good, and even the p-value is very small. Then what I did was, for the second model, I took only the variables who are very significant that I got from the first model, and doing this I got R square value as 91%, so a little bit lower than the first. And I did the predictions. Both the predictions I submitted to Kaggle, and here are the scores. For the model 1 I got 0.47, and for the model 2 0.50. So that was my project, and I would like to thank you, sir. I have learned a lot in this, in this semester. Thanks for all your support. Thank you.